Welcome to this explainer on MRI Safety. We all know it's that big machine where you have to take off all your jewelry, right? But the why behind that rule is way more intense than you probably imagine. Today, we're going to pull back the curtain on the invisible forces at play and walk through the critical steps that keep everyone safe.
Okay, let's just jump right into why this matters so much. That warning, that's not some made-up scare tactic. It's pulled straight from the official safety guidelines. It's a really stark reminder that the forces we're dealing with inside an MRI suite are no joke. They're incredibly powerful, and you've got to respect them.
And really, that's the bottom line, isn't it? To make sure something like that never happens, there's a whole system in place. Every single procedure, every question they ask you, it's all designed to make sure this amazing piece of technology is used with the utmost care.
So, what's the big deal with an MRI? I mean, how is it so different from, say, an X-ray? Well, it all boils down to one single thing: the unbelievable power of its magnet. Let's dive into that invisible force.
Okay, if you remember one thing from this, let it be this. The main magnet in an MRI machine is always on. It's not like a light switch. It never ever gets turned off, not even at night or on weekends. So there's this powerful, invisible magnetic field just sitting there, 24/7.
Now, this magnetic field is kind of picky. It doesn't care about stuff like plastic, wood, or aluminum at all. But when it comes to what are called ferromagnetic materials, things containing iron, nickel, or cobalt, the pull is absolutely immense. We're not talking about a little fridge magnet here. It's an overwhelming force. And that crazy strong pull? It has a name: the projectile effect. And it's exactly what it sounds like. It can grab a simple metal object, a pair of scissors, a wheelchair, or, that oxygen tank we saw earlier, and turn it into a high-speed missile. This is the #1 hazard that has to be controlled.
So, how on earth do hospitals manage a risk like that? Well, they get clever. The entire MRI suite is designed with a system of safety zones. Think of it like an invisible force field that controls who and what gets close to the magnet.
And here's what that force field looks like in real life. Your path into the scanner room is carefully planned. You start out in a public area, Zone I, and then you move through these increasingly strict zones until you finally get to the main event, Zone 4, the magnet room. Think of each zone as a security checkpoint. In Zone 2, that's where you'll have your safety interview. Then you move into Zone 3, the control room, which is for screened personnel only. So by the time you actually get the green light for Zone 4, you've already gone through multiple layers of safety checks.
But, how did the staff know what's safe to bring in and what's not? It's not like they're just guessing. There's a really clear, universal labeling system for every single piece of equipment.
First up, you've got MR Safe. It's got a green square logo. Super simple. These items are totally non-metallic, non-magnetic, and pose zero risk.
Then there's MR Conditional, marked with a yellow triangle. Now this is a big one. These items can be safe, but only if very specific rules are followed. Like, maybe it has to stay a certain distance away from the scanner, or it can only be used with a certain strength of magnet.
And finally, MR Unsafe, red circle with a line through it. This one's easy. These items are a huge risk and are absolutely forbidden from entering the magnet room. Period. No exceptions. So who are the gatekeepers here? Who are the people making sure all these rules and labels are actually followed? Let's meet the team that's dedicated to your safety.
All right, the person you're going to spend the most time with is the MR operator. They're usually a radiographer, and they're the one who actually runs the machine. But their most important job is being your safety guardian. They're on the front lines, doing that final screening and talking you through the whole process.
Then, working behind the scenes, you have the MR safety expert. This person is often a physicist. You can kind of think of them as the mastermind of the whole safety program. They're the go-to expert for the really complex stuff: the physics, the equipment, and especially for patients who have tricky medical implants. Okay, so we've met the experts, we've seen the safety zones, but now let's talk about the single most important person in this whole equation, and that's you. The screening process is where you become the golden key to your own safety. You know that screening form they give you? It's so much more than just a piece of paper. It's a critical conversation between you and the team. Being totally open and honest about your entire medical history is, without a doubt, the most important thing you can do to guarantee a safe scan. And this right here shows you exactly why that history is so important. See, an MRI scanner isn't just one big magnet. It uses two main forces, that huge static magnetic field and also radio frequency waves, or RF.
and they pose totally different risks. For something like an aneurysm clip, the big danger is the magnet itself. It could actually move it, which could be catastrophic. But for a pacemaker, it's a double whammy. The magnet can make it malfunction, and the RF waves can heat up its wires, potentially damaging heart tissue. It's super complex.
Now, the screening questions might get into stuff that seems, well, a little weird. They might ask you about tattoos, or permanent makeup, or even what kind of workout clothes you wear. So, what's the deal with that?
It turns out that even microscopic bits of metal can be an issue. Some tattoo inks, especially older ones, actually have iron oxides in them, and some high-tech athletic clothes have silver microfibers woven in. Now, these tiny particles aren't going to get yanked across the room by the magnet, but the other part of the MRI, the radio frequency waves, can heat them up, and that can lead to skin irritation or, in some rare cases, even burns.
All right, so you've done the screening, you've taken off every last bit of metal, you're in the hospital gown, you're ready to go. So what happens next? There are just a couple of final checks once you're actually in the scanner room.
These last three things are your final layers of protection. First, hearing protection. It's non-negotiable. MRI scanners are loud. Second, burn prevention. The staff will be really careful about how they position you and any monitoring wires to make sure your skin doesn't form a loop, because that can create a spot that heats up. And third, and maybe the most important for your peace of mind, is the panic alarm. You get a little squeeze ball, and if you press it, the operator knows instantly and can stop the scan right away. You're always in control.
So, when you boil it all down, what's the big takeaway here? It's that your safety is a team effort, and you are the MVP of that team. By telling the staff everything, by removing all the metal, asking questions if you're not sure, you are playing an active role. You're helping make sure that the incredible power of this machine is used for one thing and one thing only: to help you. It's a great reminder that sometimes the most advanced safety feature in all of medicine is just a good, honest conversation.